Question number 71 I have to take. Total number of nodes and the radial nodes present in 5p orbitals respectively are. So, if you know, the angular nodes are equal to L value. If I'm just talking about the radial nodes, the total number of the radial nodes, if been asked to find out, these are equal to n minus L minus 1, and the total nodes, that is equal to radial node plus angular node. So, in this value n minus L minus 1, if you add L, then total nodes becomes n minus 1 only. Okay. So, using this I am just going to calculate the value. Total number of nodes and radial nodes present in 5p orbital. For 5p, n value would be 5 and L value would be 1 obviously. P orbital it is. Okay. So, n minus L minus 1 would be 5 minus 1 minus 1. So, that comes out to be 3, and here the total nodes n minus 1 means 5 minus 1, it is 4. In which option it is given? 4 and 3. Yes. So, this is correctly given here in option 2. This is my correct answer. The total number of nodes 4 and the radial nodes are 3. Turn is for question number 72. 100 ml of 4 molar NaOH solution was mixed with 400 ml of 2 molar solution. Okay. And both of them are of sodium hydroxide. The molarity of the resultant solution becomes. So, this is basically the molarity equation that I am going to use. If you have the two different solutions and if you are mixing them, the simple formula we should use M1V1 for the first solution plus M2V2, the second solution, we mix them, and the molarity for the final solution is say M3, and the volume is V1 plus V2 because we mixed and the volume would be added. Okay. So, molarity is 4 molar. Okay. Volume is in milliliter, not in liter. So, let me just proceed this that ways only. I am just considering the volume in milliliter because at all the places the volume is in milliliter only. So, the same value I am going to take. Okay. M2 is 2 molar. Volume is 400. So, this can also be written as this way. M3 we want to calculate. So, V1 plus V2, how much it would be? 100 plus 400. Simple. Clear? So, 400 plus 800. Now, here 400 plus 100. 500 na? Right. Just divide it by 500. And this would be your M3 value. Solve it. Simple. 1200 by 500. So, if you solve this expression, then you will be getting your final answer as 2.4 molar. Right? So, correct answer is clearly given in option 3. Choose it, and if you have chosen it, your answer is right. Okay? Now, question number 73. Which among the following contains lowest number of molecules? So, once again, all the options we need to check for such type of questions. First option states 22.4 liter of methane at STP. So, whenever standard temperature and pressure is there, ideal gas or a gas would have the volume which is equal to 22.4 liter. It means if you want to find out the mole of methane, here those would be 22.4 by 22.4, given volume upon 22.4 liter to get the number of moles. And if you just want to find out the particles or the molecules, so I am writing here the molecules as per the question, that would be Na. So, easily it is Na. So, this will cut this way. 2 gram molecule of nitrogen. So, here 2 gram nitrogen is not given, it is given 2 gram molecules. It means gram molecules are given. So, the Na value would be 2 Na, the total number of the molecules here. Now, 34.2 gram of sugar. So, moles would be 34.2 by the molar mass of sugar is sugar cane sugar 342 gram per mole. The formula is given, you can easily calculate 342 gram per mole, and how many molecules are there into Na. So, this would be 0.1. So, 0.1 Na it would be, and then 18 ml of water. The density of water is also mentioned. Density is mass per unit volume. So, volume is 18 ml is given. right? So with the help of that, you can find out the mass. That would come out to be 18 gram mass because density is given, right? So moles of the water would be given mass by the molar mass of water, right? And how many molecules would be? 1, Na. Clear? Na, then Na, more, 2 Na, more, but they are not asking about more, they are asking about the lowest number of the molecules, 0.1 Na, the least value, right? So on the basis of this, yes, the correct answer is 34.2 gram of sugar, sucrose or the cane sugar, okay? Question number 74. If the mass percentage of zinc ion Zn2 plus in an enzyme is 0.327%, then the minimum molar mass of the enzyme will be. So the minimum molar mass of the enzyme, if you want to calculate, then one molecule should have at least one zinc ion, right or not? Yes. So on the basis of that, we will proceed. Now, the mass percentage is given. It means you have, if you have 100 gram of enzyme with you, then the amount of zinc ion would be there, 0.327 gram of Zn2 plus are there. Am I right or not? As per the question I am proceeding, okay? Then the minimum molar mass of the enzyme will be atomic mass of zinc is given, right? It means, once again I am just taking it, 0.327 gram of zinc ions are present in 100 gram of enzyme, right? The same statement I have just repeated. So if it was 65.4 gram of Zn2 plus ion, why I am taking this way? Because at least one ion would be there inside one molecule, right? So on the basis of this, whatever the mass you will be getting here would be the molar mass of that given enzyme, right? And on the basis of that, you can find out your final answer, right? Okay. So 100 upon 0.327 into 65.4. This would be the amount of the enzyme there, and now the same would be the minimum molar mass of that enzyme, okay? So calculate, your turn it is. So if you just calculate this, you will find that this will come out to be 20,000, right? And if it is this, then molar mass we just take in the units of gram per mole. I hope you know, okay? So if it is so, then easy to choose the final answer as the option 3. Now, the next question we have, question number 75. In hydrogen atom, the de Broglie wavelength of the electron in the third Bohr's orbit is. So, Bohr's radius you have already there in the question. You can easily check there. A naught is 52.9 picometer. You have the hydrogen atom. De Broglie wavelength of that electron in the third Bohr's orbit you need to find out. So, which formula we use? Rn is equals to A naught, that is 52.9 n square by z for nth shell, right? Now, in this case, they are not asking about the calculation of Bohr's radius, they are asking about for the calculation of de Broglie wavelength. So, which expression I am going to use? N lambda is equals to 2 pi r. Can I use this? Yes, I can use this, and Rn value we have to take here, because with respect to nth orbital we need to proceed, okay? So, in this case, we have to find out lambda value. So, 2 pi r n upon n. Clear? Now, just calculate Rn value from here. This would be 52.9 into, what is n value here? They are talking about third Bohr's orbit, okay? So, I am just writing here 3 square upon, what is the z value for hydrogen atom? Yes, simple, it is 1. Clear? So, the same value for Rn I am just going to keep here. So, it could be written as 2 pi into 52.9, and this is 3 3s are 9. So, 9 divided by n once again. Clear? Now, solve this. So, you will calculate this and you will find that this value comes out to be nearly 317.4, and pi value I didn't multiply it because in the options answer is given in terms of pi value. So this would be the answer in the picometer. Clear? And choose the right answer on the basis of this. Yes, the right answer is here in option number 2.